Let's take a look at the quadratic formula, the final topic in section 8.1. We began considering the standard quadratic equation ax squared plus bx plus c equals 0, where a is not 0. If we take this equation, complete the square on it, that results in the fact that the variable, which in this case is x, equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is called the quadratic formula. The discriminant of the quadratic formula is the radicand of the radical. We use the capital D to refer to the discriminant. It equals b squared minus 4ac. If the discriminant d is negative, that means it's less than 0, then ax squared plus bx plus c equals 0 has two non-real solutions. If the discriminant d equals 0, then the quadratic equation ax squared plus bx plus c equals 0 has exactly one real solution called a repeated solution. If d is greater than 0, then ax squared plus bx plus c equals 0 has two unequal real solutions. So let's look at using this information to solve some of the 8.1 exercises. Let's look at using the quadratic formula to solve 2x squared plus 7x plus 1 equal to 0. Alright, so the first thing I want to keep in mind is I don't want to determine my coefficients a, x, a, b, and c until the equation has 0 isolated on one side, and everything on the other side is in simplest form. So in this particular equation, 2x squared plus 7x plus 1 equal to 0, we see that a is 2, that's always the coefficient of x squared, b is 7, that's always the coefficient of x, and c is 1. So the quadratic formula tells me x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So for this equation, that gives negative 7 plus or minus the square root of 7 squared minus 4 times 2 times 1. And all of that is over 2 times 2. And this is how I'm going to find the value of my variable x that makes the equation true, or value or values. So let's continue to simplify this. So the variable x equals negative 7 plus or minus the square root of 49 minus 8 all over 4. So that's negative 7 plus or minus the square root of 41 all over 4. So those are my two solutions. So I'm able to give this solution set which is the set containing -7 minus the square root of 41 over 4, or -7 plus the square root of 41 all over 4. If the problem asks you to do so, then you find an approximation of these two values. So this is how I would use the quadratic formula to solve this equation.